Alright, hello and welcome to a physics tutorial. So today we will be looking through problem number 69 in chapter 27, which talks about circuits. So let's look through our question. So we have a 3 mega ohm resistor and a 1 microfarad capacitor connected in series with an ideal battery of 4 volts. So let's draw out that. So after 1 second, so the circuit is connected up and we want several rates after 1 second. So the first rate we want is the rate at which the charge of the capacitor increases, which is also the current because I is dq dt. So we use our equation for RC circuits, I equals EMF over R times e to the negative t over RC, which when we plug in our numbers we get 4 volts over 3 times 10 to the 6 ohms times e to the negative 1 second over RC, which ends up being 3 seconds. So we do all of that and you should get that, yes, you should get that your current is 9.55 times 10 to the negative 7 coulombs per second. Now, the second rate we want is the rate at which energy is stored in a capacitor. So how we do that is we take our equation for potential energy in the capacitor, Q squared over 2C. We take a derivative, which means that du dt, which is what we want, ends up being Q over C times dq dt, which is Q, so we get Q, which is C EMF times 1 minus e to the negative t over RC. I hope I read that right. So we have that over C times dq dt, which we just got. So you plug all those numbers in, and you should get that your rate of energy change is 1.08 times 10 to the negative 6 watts. So our third rate is the rate at which thermal energy is appearing in the resistor, which is equal to power. This one's pretty simple. We do power equals I squared R. I is, again, dq dt, and R is R, which they give us. So we plug those numbers in and we end up with 2.74 times 10 to the negative 6 watts. And the fourth rate is easiest of all. So the energy being delivered by the battery should be the energy being stored in the capacitor plus the energy appearing in the resistor, because that is total energy and of course conservation of energy. So we get that D is just the answers to B and C added together, which gives you 3.82 times 10 to the negative 6 watts. Thank you for watching. I hope you learned something about different rates in RC circuits. Please like the video, subscribe to the channel, and I will see you later. Bye!